Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to solve transportation problem in IBM ILOG CPLEX Optimization Studio. The transportation problem is a special type of a linear programming problem where the goal is to minimize the cost. Remember, the goal is to minimize the cost of transporting goods from multiple sources like factories, just here, factory 1, 2, 3, to the multiple destinations like warehouses, warehouse 1 and 2, subject to supply and demand constraints. Objective: to minimize the total transportation cost. Decision variables: Xij represents the number of units transported from factory I, so factory I, to warehouse J. Objective function: minimize the total transportation cost. Z is equal to the sigma, that is the summation of cost ij into xij. Constraints: supply constraints for each factory, demand constraints for each warehouse. Now let's take one case study. Suppose you have three factories, 1, 2, 3, and four warehouses, 1, 2, 3, and 4. And you need to transport goods in a way that minimizes the transportation cost. Each factory has a certain supply of goods and each warehouse has certain demand, which you can see in this table. The cost to transport one unit of goods from a factory to a warehouse is provided. Now let's see how we will solve this problem in IBM ILOG CPLEX Optimization Studio. So for this, we will create a new OPL project. Click here. Now write down the example. Description: it's a transportation problem. Make sure that these two ticks are there. Add a default run configuration and create the model. Press finish. Now we will start writing the code. We'll start with the transportation cost data. So we will have to define the transportation cost matrix, which represents the cost of transporting one unit of goods from each factory to each warehouse. Let's see how we can do this. So 2/, this is not command, just we are passing an information that what we are going to do. So data cost of transporting from factories to warehouse. Enter. Float. Cost 1 to 3. I'll explain what this is. So take square bracket and 1 to 4 equal to, again square bracket. Now what this 1 to 3 and 1 to 4 is? 1, 2, 3 and 1, 2, 3, 4. So we are creating an array. Eight, 6, 10, 9. Comma. So what this is our first row. Factory 1 to different warehouses. Next array is 9, 12, 13, 7. Just let's cross check. 8, 6, 10, 9, 9, 6, 12, 13, 7, and then it will be 14, 9, 16 and 5. 2 / to mention that this is from factory 2 to warehouses. Enter. Again, square bracket 14, 9, 16 and 5. Factory 3, 2 warehouses and semicolon. So we will have to debug this error. There is a syntax error. Let's remove this comma and see. Done. There is no problem now. So first row, comma, second row, comma, and in the last row, no comma, then square bracket and semicolon. So this is the 3 into 4 array, 3 by 4 array. What is 3 by 4 array? This one. 3 rows and 4 columns. So we have created it. So row corresponds to the factories, column corresponds to the warehouses. Now let's understand this figure. The cost of transporting from factory 1 to warehouse 1 is 8. This we can see from here also. The cost of transporting from factory 1 to warehouse 1 is 8. From factory 1 to warehouse 3 is 10. The same structure we have created here. Now next, we will have to code for the supply. So supply for each factory. Naturally, it will be integer supply square bracket 1 to 3, 1 is to 3, 20, 30 and 25 semicolon. So this array defines the supply capacity of each of these 3 factories. What this is 20, 30, 25? See, here is it. This number is here. 20, 30, 25. The maximum capacity of each factory. 1, 2, 3. This is maximum capacity. Right? And these are the cost. Okay. So the factory 1 can supply 20 units. Factory 2 can supply 30 units and factory 3 can supply 25 units. The next thing which we will have to do is to define the code for demand of each warehouse. So for 2 / demand for each warehouse. Integer demand. So what will be in the square bracket? Any guesses? Yes, it will be 1:4 because now we are working on columns. $15, 25, 10 and 25 semicolon. So these figures are 15, 25, 10, 25. So these are the demand values. The demand for warehouse 1 is 15, 2, 25, warehouse 3, 10 and 4, 25 units. Now we will have to specify the decision variables. That is, what is the decision variable? Units to be transported from factory I I am writing factory I to warehouse J. Remember, I is for the factory and J is for the warehouse. Okay, our decision variables dvar is float plus. Why I'm using float plus? Because I only want the solution in on the solution, positive solution. Fractions are allowed. Float plus x 1 to 3 semicolon. So here I should be decision variables done. So here xij, see, basically this is xij. It represents the number of units transported from factory I to warehouse J. This we want to find out. The this variable matrix should have a same size as specified here. Make sure it should have a same size. Then only we will get the feasible solution. Okay, let's proceed further. Now we will have to specify the objective function. Our objective function is to minimize the total cost because it is a transportation problem. So objective minimize total transportation cost, minimize there is some problem in the command line. Minimize sum I is for the factory, I in 1 to 3 J in 1 to 4 cost I J asterisk X I J and semicolon. Now what this thing is, just try to recall this part. Cost ij, that is a cost for transporting from factory to warehouse, and xij is the quantity. Okay, same we have done it here. So what we have done is we have multiplied xij with the corresponding cost ij, and then we want to do the summation. We want to sum the results of summing the results over all factory warehouse pairs, and this we want to minimize. Now we will specify the constraints. So the first one is supply constraint. See, let me explain this once again. Our objective is to find out what quantity should be transported from factory to warehouse to different warehouses so that it minimizes the total cost. So we want to find out X, the quantities. Let's say factory 1 to warehouse 1 is the cost is 8. Now we want to find out what quantity should be transported. Similarly, from factory 2 to warehouse 2. And then summing up, and that summation should be minimized. Okay, let's proceed further. Supply constraints. What are the supply constraints? So it is total shipped from each factory should be less than or equal to supply. It cannot exceed this. Okay, I'll explain this part also. First of all, let me write the code. For all I in 1, 2, 3, for all I in 1, 2, 3, sum J, J is for the warehouse, J in 1 to 4, X I J should be less than or equal to supply I, semicolon. So I will have to debug the error here. The cross sign is there. Yes. So this is sum. Now let's check. Still the problem is there. So I will have to write this under the constraints. Okay, then the problem will be resolved. Let's see. Square bracket. Yes. Now we will proceed further. So basically this is the supply constraints. It ensures that a total amount shipped from each factory does not exceed the factory's available supply. So this number, whatever solution we get, it should not be more than this supply. Okay, let me give you one example. / x11, okay, x11. I'm just talking about the first array, x11 plus x12 plus x13 plus x14 this should be less than or equal to 20, right? This we are specifying here. Next is the demand constraints. So again, I will write here. So this is, let us make this as constraints only. And inside this, we will write that this is my first constraint is the supply constraint. Let us make this code clear. Let us make it clean. Now I will make this as a demand constraint. So for all, now what it will be? For all J in 1 to 4, sum I in 1 to 3, X ij should be less than or equal to demand. What will be the what will write here next? Any guesses? Yes, it will be demand G, semicolon. So let me explain this code. Last time we had written x11, x12, x13, x14 should be less than or equal to 20. Now this time, what we are trying to impose, see, x1 1 plus x, we are moving in second array, x 2 1 plus x 3 1 should be equal to 15. Okay, this we will have to change. We will have to make it double equal. It should be equal to 15. See this one. 8, 9, 14, 50. Okay. So we should be able to cater the demand. Now I'll remove this also, and let's close the bracket of the constraint. So constraint, supply constraint, there is no error, things are fine. So the supply constraint is total shipped from each factory, and demand constraint is total received at each warehouse is equal to demand. Now click here, simply copy this in run configurations, press finish. Now again click on it and run this. Click OK, and we got the solutions. See here, 20 0 0 0 20 0 0 15 0 10 5 0 5. Here the solution is. Let me maximize this. Okay, here the solution is 0 20 0 0 15 0 10 5 0 5 0 20. Now let us interpret this solution. 0 20 0 0 0 20 0 0 15 0 10 5 15 0 10 5. Perfect. 0 5 0 20 0 5 0 20. Click on the solutions. So the solution, the minimum cost, the cost we can minimize, rather we will say that this is 565. Let us cross check. Are we getting the same answer? Okay. So when I multiply 8 with 0, 0, 120, 0, 0, 135, 0, 130, 35, 0, 45, 0, 100. Now if you do the total either row wise or column wise, you will get the same answer, and that is 565. So this is how we have minimized the cost, and we have also got the quantities which we should be transporting from different factories to different warehouses. So this was how we can solve the transportation problem in IBM ILOG CPLEX Optimization Studio. For more videos on IBM ILOG CPLEX Optimization Studio, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also join me on different social medias, the link given in the description box.